Now, I've built lots and lots of apps on this channel, but there is one type of app that I've never built. In fact, I've never built this type of app in my life, and that is a game. You see, all my life, I've been an app developer, and I've never built games before. In fact, I don't even know where to start. Building a game, getting into game development is like learning a foreign language for me. I simply do not know where I would begin and what I need to do. But actually, I've been using ChatGPT for a lot of different projects lately. I've been making lots of videos. I've been consulting it for different ways of building different apps. And so I asked myself, what if I can ask ChatGPT to either build a game for me or at least help me build a game? And that is exactly what I did. And so in today's video, I'm going to be showing you my first ever game that I built in my life. And this is actually a fun game. I was playing it a little bit last night. I've been playing it this morning. It's built using a no-code app builder. And the coolest part is that I launched this game on the web. And so you will be able to play it as well. And you can then let me know what you think about it too. Now, before we begin, as always, all the apps that I build or demonstrate in my videos are going to be available to view and or clone from my Patreon page. And you're going to see a link to it in the description below. And so the first thing that I did is I went over to our trusty ChatGPT and I told it, I like tic-tac-toe. Can you give me other similar logic puzzle ideas? And so it said, sure. Here are some other logic puzzle ideas that you might enjoy if you like tic-tac-toe. And so it gave me a bunch of ideas. And out of all of these ideas, I like this one called Gomoku. And it said, Gomoku is a two-player strategy game played on a grid. Players take turns placing stones on the board with the goal of getting 5 stones in a row horizontally, vertically, or diagonally. And so immediately I thought that this is going to be an interesting game to code and to build and to play against the computer. And so I asked it another question. Okay, I said, show me an example of Gomoku. And so it said, sure, here's an example of a Gomoku board. And so it gave me a board, and then it told me to play Gomoku, you take turns placing either X's or O's on the board. The first player to get 5 of their symbols in a row, horizontally, vertically, or diagonally, wins. Here's an example of what the game might look like after a few turns. So as you can see, we have 2 players. Okay, so we have the X's, which is 1 player, and the O's are another player. So maybe 1 player is you, another player is the computer. And so as you can see, nobody is winning right now because a player needs to get 5 of their symbols in a row. So there's no, I can't see 5 symbols being in a row. And so it says here, in this example, X and O have each placed several pieces on the board. O has 2 in a row in the second row and is trying to connect them, okay? While X has 2 in a row diagonally and is trying to build from there. So as you can see, it's diagonally right there. Okay, there's also diagonally here as well. And so at this point, I understood what kind of game I want to build. I understood exactly what the game needs to do. And I started to think how I can take the idea for this game and build it using a no-code tool such as Flutterflow, which is my favorite no-code tool at the moment. And so once I understood how this game is going to be structured, I asked ChatGPT for more ideas. So I said, write me a Dart function that, given an array of strings in a board of size n, checks if a player has 3 of their symbols in a row, okay? So horizontally, vertically, and diagonally. And actually, ChatGPT went ahead and gave me an answer. So it gave me an algorithm, and that way I can use this code to check if a certain player, whether it's me or a computer, has their symbols in a row, okay? And remember, when we were initially building this game, it mentioned 5, but this could be any number. It could be 3, it could be 5, it could be 6. As you're going to see, it's completely flexible. once I understood what kind of game I'm going to be building and how this game is going to play out, when I'm making the move, the computer is making the move, I went ahead and drew a high level diagram just to kind of better make sense of how everything is going to function. And so here's the basic high level diagram for the game. We're going to draw the board and then we're going to make the move first. So the user is going to make the move. So if I'm playing, I'm going to be making the move first. If I win, that's it. It's over. It's going to display a message. Congratulations. If I don't win, the computer is going to make the move. And this is where it's getting interesting. Okay. Now the computer can do various things. And this is also an area where I consulted ChatGPT to give me some ideas of how a computer can make intelligent moves, not just regular moves, but smart moves where it can win. And I'm going to show you some of the code a little bit later. But what happened here is that the computer will check if it can win in one move, then yes, it needs to make that move. If not, can it block the user, right? Either it's going to win. If not, can it prevent me from winning? Okay, so it's going to block the user. If not, it's going to make some other move. And this is something we're going to be covering a little bit later in the video because there's some interesting things happening here. Now, in all of these two situations, we're going to come back out and the user is going to make a move again. But if the computer wins, that's it. We're going to display congrats and the game is over and we need to start over. And so now that you've seen a high level diagram, you kind of understand how the game works. Let me show you the app that I built where you can play against the computer. And so here I am inside of Flutterflow. And what I'm going to do is I'm going to start a test environment. I'm going to show you how the app works. And then we're going to jump back into Flutterflow and I'm going to show you exactly how I build this game so that you can build one yourself. But moreover, there's so many interesting bits and pieces that you're going to learn that you can apply to pretty much any kind of app that you want. So we're going to create a test environment right now. And here's the main board. And you can pick a different level, which we're going to do a little bit later. But right now we have a 4x4 board. And the idea here is that being this is a 4x4 board, we need to get our pieces 3 in a row. So whoever gets their pieces 3 in a row, either vertically, horizontally, or diagonally, wins. So I start first, I place my X here, the computer places it here. I place another X here, and the computer sees that I might win. So it places a node there, but I can still win here. And if I do that, I get a message called I won. Okay, that's it. It's over. Now we can change the level. So let's say we want to play 5x5. I pick 5x5. We have a new board. And now you have to place 4 pieces together. So either horizontally, vertically, or diagonally, being this is a 5x5 board. So I'm going to start here. The computer starts here. I'm going to start here. I'm going to start here, maybe here. And that's it. Computer won, and we just saw the message here. And that is because I did not see that the computer is quickly building a consecutive pieces here. Okay, so we can start over. And let's say I start here, computer does here, I start here, I do this, computer blocks me. Okay, and now I maybe want to build a line, and the computer won. Okay, they got 4 in a row horizontally. So let's try another level. Let's try 7x7. And in this level, you need to get 6 pieces consecutively, right? So either horizontally, vertically, or diagonally. So I'm going to start here. Computer starts here. I'm going to do this, 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 maybe this. And computer blocks me, but I have this one right here. I won. Okay, we can start over. This, this, this. Okay, it blocked me here. I'm gonna block it here. Let's do this. Okay, and it's not blocking me. Okay, so I need 6 in a row. Okay, that's why I thought it's 5 in a row. So that's not gonna do anything. So I'm gonna come here and I need 6 in a row. Okay, let's do this, and that's 5, 6. I won. Okay, so you can go back to another level if you want. You can start over the same level, and most importantly, you can play this game right now. I'm going to have a link to this game that's launched on the web right now. So as you can see, it's a pretty fun game. I actually enjoyed playing it, but there's so many things happening behind the scenes that we need to talk about. So let's go ahead and jump back inside of Flutterflow and let me show you how I built this game so you can do something similar. or at least take this knowledge and apply it to pretty much any other app that you may be building. All right, so here we are back inside of Flutterflow. And the first thing that we need to understand is we need to have a way of storing this data one way or another. You need to store this data. You need to store the board. You need to store some of the things happening. That is the first thing you need to think about. And in this case, we don't really need Firebase Fire. So we can just use good old app state. So if you click on app state, I have a bunch of variables here. So for instance, we have a board here, and this board is a list of strings, right? Because all we're doing is storing characters, which are essentially string. And it's an empty board, but we're going to initialize it when the app runs. We also have a board size, which means 4, and 4 is 4 by 4. That's what it means. So the size is going to be 4 times 4, 16 pieces, but I'm only storing it as kind of the number of either columns or rows, right? It's just an easier way for me to kind of visualize it. And here I have another variable called inline needed. And this is the variable that dictates how many pieces must be in consecutively, right? So we start out with a board 4 by 4, and being a 4 by 4, we're going to subtract 1, and we're going to get 3, which means that we want to make sure that the winner has 3 pieces consecutively. Okay, so that's our initial state. If we go back here, if we go to the app here, what we're doing here is we have a home page, we have a column, all standard things. And then we're using a grid view. Okay, we're using a grid view to display the board. Okay, so if I click on this grid view, we are feeding this grid view using generate dynamic children from the board, right? So I'm using my app state board, and I'm breaking up those elements, those individual strings, into items, right? And then I feed them on this grid view. Now, you may have noticed I'm using a stack here. Why am I using a stack? Well, the reason I'm using a stack is because if you pick a level, right, we have this pull down or drop down is what it's called. And if you change this drop down, it's going to change how many elements are going to be placed in a row and a column. The problem is in the grid view here, we can't specify that dynamically. And so one workaround is by having them all inside a stack. And that way I have 4 grid views of different sizes. So this grid view is, for instance, 4 by 4. This grid view is 5 by 5. This grid view is 6 by 6, and this grid view is 7 by 7. And so that is a nice workaround, nice tip if you're using widgets, but they do not have kind of dynamic values that you can pull them all, put them under a stack, and that way you can iterate them, right? And obviously I have here, I have conditional visibility, right? So I'm saying board size is 4, I'm saying board size is 5, etc., right? Pretty self-explanatory. I've used this technique in some of the other apps, but still a very, very underrated technique. Now, what happens here next is we display the board, right? So when the app loads, we have the home page, we have this action here. And if we open this action here, we just have update app state. And what we're doing here is we're initializing the board. Remember, initially, this board doesn't have any elements, right? That's why when the app loads, we have this custom function called init board that initializes the board. We pass this board, this app state. And what this function is doing is it returns a list filled by this size. This is board size by board size. So if it's 4, it's going to be 16. And then I am putting ease, which is the string that, I'm storing. E means empty. Okay, now we're not going to display this E, but internally, that signifies empty because we're also going to have X's and O's, but the E means empty. Okay, and so when we actually display it, right, in this grid view, I have a code expression. And what the code expression is doing is it checks if it's E, we're going to display empty. If it's not, we're going to display the actual value. Okay, code expressions come really, really handy. Okay, so very, very basic stuff so far. Now let's get to the meat of the app, right? When we click on something, remember, we have the first move. So the app is not doing anything until we do something, right? So what we have here is we have a grid view, we have a container, and then we actually have the text. And so if we go to this container here, we have an action, right? This is an action that happens when we click on the container, when the person wants to make the move. We're going to open this up. And what we need to do here is we need to update app state. The first thing we need to do is we need to place the user's move wherever they clicked. And so what I'm doing here is I have move user. basically user's move. This is move user. There's also move computer. That's how I name these functions. But right now it's move user, and we are passing the index in the list, right, that we are getting from the items. The items that are being displayed, they have an index. And that is the position in the board, on the board where the user clicked. And we can get that using this item list, index and list. And then we also have the board. And so we are essentially executing this move user function. And this is a very, very short function, right? We have a board, we get the index, and we're just saying board index, put an X in there, right? That's, in other words, we have, a list of strings, which is the board. And this is our kind of a subscript, right? And so if you do something like this with these square brackets, you can you have a way of specifying the exact position inside that list, inside the board where the user clicked. And remember, we're passing the index via this list index that I just showed you. So very, very quick and easy function. We just need to place X there, okay? So this is all simple. The next thing is we need to check a winner. Okay, so we have a function called check winner, and we are passing the board. We are passing the player, right? We need to pass the player is actually the string that we need to check for, right? Because we need to pass the player's string, the player's character is X. Okay, and so in this case, we need to check, is the user winning, meaning myself, if I'm playing the board, or maybe if you're playing the game. And then we also need to pass the sequence, right? How many of these need to be consecutive? And this is also stored in our app state, which by default, when you start out, it's a 4x4 board with 3 being, you need a minimum of 3 to be consecutive. And so that is the function. Now, this function is a little bit more involved. This is the function right now. But this is the function that I got copy from ChatGPT, because if you go back to my interaction with ChatGPT, I have actually a function that I asked it to build out. Said, write me a Dart function that, given an array of strings on a board of size n, checks if a player has 3 of their symbols in a row. Okay, and it basically came up with this function. And so it basically generated this function where it's checking horizontal rows, it's checking vertical columns, and it's also checking diagonal rows, right? And also reverse diagonal rows. And if any of these match, it returns true. If nothing matches, by default, it returns false. And this is important because if you go back to the app here, remember, we have this flow here. If it's true, okay, the user has won, show them a snack bar. Okay, I just have a quick snack bar. It's half a second just to show something. If it's false, we need to update app state, okay? And we need to move the computer, right? And so what we need to do here is we need to execute this function called move computer. The thing is here is that inside actions, you can't execute functions directly. You need to manipulate variables, right? You need to manipulate data. So what we're doing is we're updating app state, we're updating the board, but we are updating with the value that we got from move computer, right? So if we edit this function here, this is the computer. And so here is another function that's going to modify the board by placing the computer's move. And this function that ChatGPT generated is truly amazing. I basically asked it to build this function for us. And I said, we have a board that looks something like this, where a computer plays with O and user plays with X, and E meaning empty slot. Write me a function that regenerates the list, meaning this board, by replacing some E with O in an effort to get n consecutive O horizontally, vertically, or diagonally. Make one intelligent move, okay? And it actually went ahead and generated this logic here. And this is really the heart of this game here, right? Because, my moves, the user moves is easy. I click on it, I change that value with my X or whatever. That's easy. It's the computer's move that's kind of interesting, it's challenging. And so this is what it came up with, which I found really, really fascinating. It said, first, we're going to check if a computer can win in one move. And so it's looking through all the available places, and it places it there temporarily, and then it checks, okay, did we win or not? Okay, if it did, it just returns that board because we won, right? We won. If not, it's going to go to the next one. Here it checks if opponent can win in one move, and then we can block it. Okay, so this is smart, right? First, it tries to win itself. If it cannot win in one move, it's going to try to block me. Otherwise, if no immediate threats or opportunities, make a random move. Okay, And so this is kind of what it came up with. It basically makes a random move. It places its O anywhere where it's empty, essentially, okay? And then so it has some logic for a random, generating new board, etc., etc. And I found this absolutely fascinating. I found it so fascinating that I went back to Flutterflow and actually changed this code around, and I made it even smarter. So let me show you what I did. And so here's the code, and the first half, I basically copied and pasted it from ChatGPT. But here I decided to make it a little bit smart. And so remember, in the code that ChatGPT gave me, it's only checking if the computer can win in one move. Well, one way to make it a more intelligent move is to check if the computer can win it in two moves or in three moves, right? Instead of simply giving up because it can't win in one move and simply placing its O randomly in the game. And so what I did is I took this code where it says if computer can win in one move, and I changed it a little bit where we are trying to see if the computer can win in three moves, because thinking ahead in moves is better than placing that O randomly somewhere. And so here we are back in the game, and let me show you how this interesting piece of logic works. If I start here, the computer starts here, it checks. Can the computer win? No. Can the computer block me? No. So it's just going to pick it, in the first available place, which is this corner here. This is 0 actually. And I'm going to do here. The computer still cannot really, it cannot win. It cannot block me. And so instead of placing its O randomly, which is what it would have done with the initial code, it's calculating, it's looking ahead, and it sees that it can win possibly in three moves, because being a 5x5 board, it needs to have four in sequence consecutively. So it knows that, well, it cannot win in one move because it needs three more moves, but it can win in three moves. And this is the code that I implement. And so if I do this, computer sees that it cannot win in one move, and it doesn't need to block me yet because I cannot win in one move also. And so it keeps doing it. And at this point, the computer can win in one move. That is by placing a no here. So if I place it here, the computer is not going to block me because it sees it can win in one move. So if I do that, it places it here, you lost. Okay? And so I made a little bit of a change. And so instead of thinking one move ahead, I made it to think multiple moves ahead. And there's still tons of things that you can do here to make it even smarter. And so that is the code for move computer. And then what we have is, again, we're checking, did the computer win, right? The board has changed. Remember, we changed the state of the board. We need to check, is anybody winning? And in this case, we have check winner. But in this case, I'm checking if the computer is going to win. So I'm passing the O, which is the computer's characters, the computer's symbol. And the sequence is all the same. And so if it's true, we say you lost, meaning the computer won. And if this function returns true, we are going to respond with you lost, meaning that the computer has won. If it's false, we're not going to do anything. And in this case, I need to take another turn, and this whole flow starts from the beginning. Now, I also decided to spice this game up a little bit by adding this choose a level functionality. So what we have here is a drop down widget here. And that widget is configured with 4 possible options. So 4x4, 5x5, 6x6, 7x7. And I also defined the values, right? Because this thing right here, it's not very helpful. I need the actual number, right? So for these values, I also define values 4, 5, 6, 7, which is the size of the board. Remember, we're not using the number of all the elements. We're just using kind of the square root, if you will, of the number of all the elements. So if it's a 16 board, it's 4x4, and we're just using this 4. If it's 25, then it's 5x5. And so on this drop down here, if we click on the actions, we have 2 actions here. And what we're doing here is, once we change that drop down, we need to update board size and inline needed. Board size is input size, and inline needed, we are basically subtracting 1 from board size. So if it's 5x5, you need to have 4 consecutive. 6x6, you need to have 5 consecutive, etc., etc. And the other thing we're doing is we're also reinitializing the board. Okay, we're basically starting the board from scratch. And here we are essentially calling this function called initBoard, which is called when we initially load the app. And in this case, we are doing this as well. We also have a button called Start Over, which basically refreshes the board without changing the level. And so this right here essentially executes the same thing that happens when we launch the app. We basically clear the whole board so that the user can start from scratch. And as a result, we have a pretty fun game. So I can start over, I can play it again, I can change the level, I can, start maybe with a smaller board, larger board, etc., etc. And so this is a pretty fun game. And the best part, like I said, you can play it right now. I'm going to have a link in the description. Definitely check it out. Let me know what you guys think. And so I was super excited to be able to build a cool logic puzzle game that I played and I actually enjoyed. And so if you're watching this video and you're thinking to yourself, that is a cool game, but I want to change it around. I want to change some of the features. I want to maybe create a different game based on this game. Or maybe you're thinking, James, that is a really, really cool app, but I'm more interested in seeing kind of the low level details, seeing how everything was done, and actually taking this app and looking at it the way you're looking at it right now, being able to clone it, being able to view it, being able to clone it, being able to kind of study. And if that is what you're thinking, then you definitely need to become a member of my Patreon, because when you join my Patreon community, not only will you be able to view and or clone pretty much all the apps that I built on this channel, all the Flutterflow apps, as well as some of the other apps that are all there, but you also get access to extra content such as Q&As, live streams, behind the scenes content, as well as our exclusive supporter only masterclass series where I do a deep dive of different topics that the community votes on. In fact, I'm going to be doing another masterclass later this month. I'm going to ask the community what they're interested in. We're all going to vote together. We're all going to decide together which topic the community is interested in seeing a deeper dive. And that is something I'm going to be doing exclusively for our Patreon members. Plus, most importantly, when you join our Patreon community, you're going to be supporting this channel and supporting my work, which is greatly, greatly appreciated. And so if that is something you might be interested in, definitely check out our Patreon community using the link below this video and consider becoming a member. Now, if you guys enjoy this video and you're looking for more videos having to do with AI, having to do with GPT, ChatGPT, definitely check out the video you're seeing in the corner of your screen right now. That video is going to further help you make sense of it all and help you build incredible apps.